Okay, so today we're going to be doing question 104 for LeetCode. That's maximum depth of binary tree. So in the question, you're given a root of binary tree, and you want to return the maximum depth, right? So here it says binary tree's maximum depth is the number of nodes along the longest path from the root node down to the furthest leaf node. So what this means is starting from your root node, which in this example is 3, you want to go to the furthest leaf node, right? So the furthest is 3, 20, and 7, right? So because of that, you see how there are 3 nodes, the root, this one, and the leaf right here. That's why your output is 3. So you need to kind of find out the max if it's either going to be left or right, and then just spit it out. So how are we going to go and do that? Well, the first thing we're going to do when you're working with these binary tree questions is you have to think of two things: recursion and edge cases, right? So edge cases are basically snippets of code that tell the program when to stop when a certain condition is met, and you most of the time specifically kind of use that when using recursion. And recursion is what we use in binary trees is when we call the function within itself, right? So it's kind of like a while loop and it continues going. So now as we have an idea, let's try to think of an edge case, right? A most famous one is, let's say we're traversing through left and right and we hit the last node, right? If we hit the last node, we kind of want to tell the code, hey, like there's nothing else we can kind of progress to, we should stop, right? So that is an idea that we need to implement, right? So if we have no more nodes, stop. How we write that is if not node, right, then return none. So what this is basically saying is, or not none, I mean return 0. So what this is saying is, okay, so if there's no more nodes, right, then just return 0 because there's nothing else we could do here. So that's our first edge case. And then after that, we need to kind of traverse, right? We need to traverse left and right. How do you do that with binary trees? Well, what um, you could do it two ways, but one way I like to do it is kind of creating variables for it. So you have left and right. Left is going to traverse through the left side of the tree, and right is going to traverse the right side of the tree, right? So what you do is, remember how I mentioned you're going to go and call the function that you're in for the recursion step? Well, that's exactly what we're doing here. So left equals the function we're in, and within the argument, we have our root here, right? We're going to do root.left. Now this is going to um, the left side of the tree, and the right is going to be the same thing, but instead of left, root.right, right? So this is awesome. Now we kind of have these two variables which will go to the left and right, but we want them to continue going, right? Because in this instance, it just moves left and it moves right once, right? Like we want it to continuously be updating and so on. So we need to make a return statement, right? Once we make the return statement, these two lines run, right? And then we get to the return statement and we can kind of keep on going back and forth. So let's think about what the outcome that we're trying to get is, right? We're trying to get the max side, right? Because we're trying to find the maximum depth. So if you haven't gotten it yet, right? We should, when we hear max, we should automatically kind of be thinking of the function max, right? Because we're trying to find the maximum depth. So let's start off with something we do know, that we're going to return something, so return. And we want to get the maximum of left or right because we're trying to find the maximum depth. And we're moving left, we're moving right in the binary tree. So with that being said, it's like, okay, well, return max of left or right. And we do need to add just one more thing, which is we need to make sure that we add the root, because left and right just kind of add the values under the root. We need to make sure to include the root. So we just do a +1 like this. So we have return 1 plus and then the max of left or right. This line here is basically saying, okay, left is going to traverse to the left side of the tree. Right is going to traverse to the right side of the tree. It's going to find out which one is the largest. In this instance, right is. and it's going to return right. So right would be 20 and 7, right? So this would be 2, and we're adding 1, right, because of the root. So we have 1, we have 1 plus 2, right? And the output with this is 3. And if you look at the example, the output is 3. So with that being said, let's see if the code is right by giving it a run. Oh, if root is none. I forgot to write that. If root is none. Oh, okay, one last thing. There needs to be a self here. The reason for this is because we have a function within a class. Once you do that and you do recursion, you need to make sure you use the self method. There you go. All right, I promise you is one more thing. Let's give it a submit to see if we make sure we have all the test cases locked and loaded. And there you go. Perfect. So some key things to take away from this question are when working binary trees, the first steps are thinking edge cases, right? This edge case in particular is literally universal. Like you're probably going to have this in every single question. Then in order to traverse through a tree, you can create functions, or variables, I mean. In this instance, I made variables left and right. We use recursion to call the function, and within the argument, do root.left and root.right. But how this looks like on paper is the left will only go to 9 and right will only go to 20. And we want left and right to continue to be updating and to keep track. So in order to do that, we need a return statement, and we're returning 1 for the root plus the max of left or right.